NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. Welcome to our math lesson. Today we'll learn about solving exponential equations using logarithms. First, let's understand what logarithms are. The logarithm of a number is the power to which a given base must be raised to produce that number. For example, log base 10 of 100 equals 2 because 10 raised to the power of 2 equals 100. Logarithms have several important properties that help us solve equations. First, the logarithm of a product equals the sum of the logarithms. Second, the logarithm of a quotient equals the difference of logarithms. Third, the logarithm of a power equals the power times the logarithm. Let's start with our first example. We need to solve 2 to the power of x equals 8. To solve this equation, we need to isolate the variable x. We can take the logarithm of both sides. Since logarithms and exponents are inverse operations, taking log base 2 of both sides gives us log base 2 of 2 to the power of x equals log base 2 of 8. Using the property that log base b of b to the power of x equals x, we can simplify the left side to just x. Now we need to calculate log base 2 of 8. We can write 8 as 2 cubed. So log base 2 of 2 cubed equals 3. Therefore, x equals 3. Let's try a more complex example. Solve 3 to the power of 2x minus 1 equals 27. Let's solve this step by step. First, we take the logarithm base 3 of both sides. This gives us 2x minus 1 equals log base 3 of 27. We can simplify the right side by writing 27 as 3 cubed. So log base 3 of 3 cubed equals 3. Now our equation is 2x minus 1 equals 3. Adding 1 to both sides, we get 2x equals 4. Dividing by 2, we find x equals 2. Welcome to this math lesson. Today, we'll solve an exponential equation step by step. Let's look at our example. We need to solve the exponential equation 7 raised to the power of x equals 9. To solve this equation, we'll use logarithms. First, we take the natural logarithm of both sides of the equation. Now, we use the logarithm property that states the logarithm of a power equals the exponent times the logarithm of the base. So, ln of 7 raised to x equals x times ln of 7. Next, we isolate x by dividing both sides by ln of 7. This gives us x equals ln of 9 divided by ln of 7. Now, let's compute the numerical value. We substitute the values. ln of 9 is approximately 2.197224558, and ln of 7 is approximately 1.945911015. Dividing these numbers, we find that x equals approximately 1.129150007. It's worth noting that we would get the same answer if we used the base 10 logarithm instead of the natural logarithm. Let me demonstrate this alternative approach. Let's restart with our original equation. First, we take the logarithm base 10 of both sides. Again, we use the logarithm property, which gives us x times log base 10 of 7 equals log base 10 of 9. Isolating x again, we get x equals log base 10 of 9 divided by log base 10 of 7. Substituting the numerical values, log base 10 of 9 is approximately 0.954242509. and log base 10 of 7 is approximately 0.845098040. Computing this division, we again get x equals 1.129150007, which confirms our earlier result. Therefore, the solution to our exponential equation, 7 raised to the power of x equals 9, is x equals 1.129150007. We can verify this result by plugging it back into the original equation to check that 7 raised to the power of 1.12915 is approximately equal to 9. Thank you for watching this lesson on how to solve exponential equations using logarithms. Welcome to this video where we'll solve an exponential equation. Let's carefully work through this example step by step. Let's begin solving the exponential equation 2 to the power of 4, y plus 1 minus 3 to the power of y equals 0. Our first step is to isolate the exponential terms by moving 3 to the power of y to the right side of the equation. Next, we take the natural logarithm of both sides of the equation. This allows us to bring down the exponents using the properties of logarithms. Now we apply the logarithm power rule, which states that the logarithm of a number raised to a power equals the power times the logarithm of the number. That is, log of x to the power of it equals a times the log of x. Applying this rule, we get left side becomes 4y plus 1 times the natural logarithm of 2, and the right side becomes y times the natural logarithm of 3. Now, let's expand the left side of the equation. We distribute the natural logarithm of 2 to both terms in the parenthesis. To solve for y, we need to rearrange the equation so that all terms with y are on one side and all constants are on the other side. So we subtract y times the natural logarithm of 3 from both sides and move the natural logarithm of 2 to the right side. Now, we can factor out y from the terms on the left side of the equation. Finally, we can solve for y by dividing both sides of the equation by the term in parentheses, which is 4 times natural logarithm of 2 minus the natural logarithm of 3. Welcome to this math tutorial. Today, we'll solve an exponential equation step by taking logarithms of both sides. Let's start with our example. We need to solve the equation e to the power of t plus 6 equals 2. The first step is to take the natural logarithm, or ln, of both sides of the equation. This gives us ln of e to the power of t plus 6 equals ln of 2. Next, we use the logarithm power rule, which states that the logarithm of a power equals the exponent times the logarithm of the base. So ln of e to the power of t plus 6 equals t plus 6 times ln of e. We know that the natural logarithm of e equals 1, that is, ln of e equals 1. So our equation simplifies to t plus 6 equals ln of 2. Finally, we solve for t by subtracting 6 from both sides. This gives us t equals negative 6 plus ln of 2, which is our final answer. Let's verify our answer by substituting it back into the original equation. If we substitute t equals negative 6 plus ln of 2 into e to the power of t plus 6, we get e to the power of negative 6 plus ln of 2 plus 6, which simplifies to e to the power of ln of 2, which equals 2. This confirms our solution is correct. To summarize, we solved the exponential equation e to the power of t plus 6 equals 2 by following these steps. First, we took the natural logarithm of both sides. Second, we applied the logarithm power rule. Third, we used the property that ln of e equals 1. And finally, we isolated t to get our answer. T equals negative 6 plus ln of 2. Welcome to this mathematical video. Let's solve the following exponential equation. Let's solve this step by step. First, we need to isolate the exponential term. We'll move the negative 8 to the right side of the equation. Next, we'll divide both sides of the equation by 5 to isolate the term with e to the power of 2z plus 4. Now, we'll take the natural logarithm, or ln, of both sides of the equation. This is a key step when solving exponential equations. We can use the logarithm property that states ln of e to a power equals that power times ln of e. So ln of e to the power of 2z plus 4 equals 2z plus 4 times ln of e. Since the natural logarithm of e is equal to 1, we can simplify our equation further to 2z plus 4 equals ln of 8 over 5. Now, we'll isolate the term with z by subtracting 4 from both sides. Finally, we'll divide both sides by 2 to isolate z. So our answer is z equals 1 over 2 times the quantity ln of 8 over 5 minus 4. Let's solve the following exponential equation. 7 plus 15 times e raised to the power of 1 minus 3z equals 10. To solve this equation, we'll first isolate the exponential term. We'll subtract 7 from both sides of the equation. Next, we'll divide both sides by 15 to isolate e raised to the power of 1 minus 3z. Now, we'll take the natural logarithm, or ln, of both sides. We know that the natural logarithm of e raised to a power equals that power. So the logarithm of e raised to the power of 1 minus 3z equals 1 minus 3z. Since the natural logarithm of e equals 1, we can simplify the left side. Now, let's isolate the term with z by subtracting 1 from both sides. Finally, we'll divide both sides by negative 3 to find the value of z. And that's our final answer. Let me explain what we have. Z equals term with z by subtracting 1 from both sides. Finally, we'll divide both sides by negative 3 to find the value of z. And that's our final answer. Let me explain what we have. z equals negative 1/3 times the quantity, -1 plus the natural logarithm of 1/5. We can further simplify this by evaluating the natural logarithm, but this is our exact solution in terms of logarithms. This problem demonstrates how to solve an exponential equation using properties of logarithms. Remember the key steps. Isolate the exponential term, take the natural logarithm of both sides, and then solve for your variable. Thank you for watching. Isolate the exponential term, take the natural logarithm of both sides, and then solve for your variable. Thank you for watching. Welcome to our math tutorial. Today, we'll solve an exponential equation, step by step. Let's solve the following exponential equation, x minus x times e raised to the power of 5x plus 2 equals 0. First, we'll factor out the common term x from both terms on the left side. We apply the distributive property to factor out x, which gives us x times the quantity 1 minus e to the power of 5x plus 2 equals 0. Now, we can apply the zero product property. If the product of factors equals 0, then at least one of the factors must be 0. So either x equals 0, or 1 minus e to the power of 5x plus 2 equals 0. Let's focus on the second case, where 1 minus e to the power of 5x plus 2 equals 0. We'll solve this equation to find the corresponding value of x. Next, we need to isolate the exponential term. We'll add e to the power of 5x plus 2 to both sides of the equation. This gives us 1 equals e to the power of 5x plus 2. To eliminate the exponential, we take the natural logarithm of both sides. This gives us the natural logarithm of e to the power of 5x plus 2 equals the natural logarithm of 1. Now, we can apply the logarithm property that states the logarithm of a power equals the exponent times the logarithm of the base. In our case, since we're using the natural logarithm with base e, we get 5x plus 2 equals the natural logarithm of 1. The natural logarithm of 1 equals 0. So our equation simplifies to 5x plus 2 equals 0. Finally, we solve for x by subtracting 2 from both sides, and then dividing by 5. This gives us our final answer, x equals -2/5. So our solution set has two values, x equals 0, which we found from the first case, and x equals -2/5, which we found from the second case. Remember, when solving equations with exponential terms, we often need to use logarithms to isolate the variable in the exponent. Welcome to this math video where we'll learn how to solve an exponential equation. Let's take a look at our example. When solving exponential equations, our first goal is to isolate the exponential terms and try to get them on opposite sides of the equation. Let's move all terms to one side first. Next, we'll divide both sides by 4 to isolate the first exponential term. Now, we can use a key property of exponentials. When we divide two exponential expressions with the same base, we can subtract their exponents. So e to the power of 1 plus 3x divided by e to the power of 5 minus 2x equals e to the power of 1 plus 3x minus the quantity 5 minus 2x. Let's simplify the expression in the exponent by distributing the subtraction. 1 plus 3x minus 5 plus 2x. Now we'll combine like terms in the exponent. 3x plus 2x equals 5x, and 1 minus 5 equals -4. To solve for x, we'll take the natural logarithm of both sides of the equation. The natural logarithm function, ln, is the inverse of the exponential function, so it will help us isolate the variable x. When we take the natural logarithm of e raised to a power, we get the power itself. This is a fundamental property of logarithms. Now we'll solve for x by first adding 4 to both sides of the equation. Simplifying the left side, we get 5x. Finally, we divide both sides by 5 to isolate x. Therefore, our solution is x equals 1/5 times the quantity 4 plus the natural logarithm of 9/4. This is the exact answer in terms of logarithms. To summarize, we solved this exponential equation by first, isolating the exponential terms on opposite sides. Second, using properties of exponents to combine the exponential expressions. Third, taking the natural logarithm of both sides. And finally, solving for x through algebraic manipulation. This approach works for many types of exponential equations where the bases can be expressed in the same form. The equation we need to solve is 3 raised to the power of 5 raised to the power of x equals 5 raised to the power of 3 raised to the power of x. This equation looks quite complex because it involves nested exponents. When solving equations with nested exponents like this, we often use logarithms to simplify the problem. A key property of logarithms that we'll use is that the logarithm of a number raised to a power equals the power times the logarithm of the number. In mathematical notation, that's log of a raised to the power of b equals b times log of a. Let's start solving our equation. The first step is to take the logarithm of both sides. This will help us bring down one level of exponents. Now, we can apply our logarithm property. The logarithm of 3 raised to the power of 5 to the x equals 5 to the x times log of 3. Similarly, the right side becomes 3 to the x times log of 5. Let's combine these equations. We get 5 to the x times log of 3 equals 3 to the x times log of 5. Now, let's rearrange the terms to isolate the exponential expressions. We can divide both sides by log of 3, and then divide the right side by 3 to the x. This gives us 5 to the x equals 3 to the x times log of 5 divided by log of 3. Let's move all exponential terms to one side. We can divide both sides by 3 to the x. This gives us 5 to the x divided by 3 to the x equals log of 5 divided by log of 3. We can simplify the left side using the properties of exponents. 5 to the x divided by 3 to the x equals 5 divided by 3, all raised to the power of x. We've made great progress, but we still need to solve for x. Let's take the logarithm of both sides again. Taking the logarithm of both sides gives us log of 5/3 to the power of x equals log of 5 divided by log of 3. Using our logarithm property again, we get x times log of 5/3 equals log of 5 divided by log of 3. We can expand the logarithm of a fraction on both sides. The left side becomes x times log of 5 minus log of 3. For the right side, log of a fraction equals log of the numerator minus log of the denominator, so we get log of 5 minus log of 3. Now we can solve for x by dividing both sides by log of 5 minus log of 3. This gives us our answer, x equals log of 5 minus log of 3, divided by log of 5 minus log of 3. This is our exact solution. To find a decimal approximation, thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.